So there are two principles involved here. One is Bernoulli's theorem, as we saw earlier, and then there is Newton's law as well. So let's now understand how Bernoulli's theorem works in this setup and how it uses because how the combination of Bernoulli's theorem and Coanda effect kind of is able to generate lift. So let's quickly have a look at. So this is the turbine or the impeller. In both cases, as the air is being pushed out, because of the curved surface of the paper in one of our examples, and as well as the impeller setup, the air tends to stick to the surface and it flows down. Okay, so since it is curved, the air tends to stick to the surface and it flows down. Now, looking at Bernoulli's theorem, here since the air is in motion compared to here, if you see that there is no air or there is no air in motion here, the air is pretty much static. So since the air is static, which means that it is in low velocity, the pressure is high. So we have high pressure here, and since here the air is in motion, there is high velocity, which means there is low pressure. So we know that. So here is where Bernoulli's principle comes into the picture, saying that since the air is in motion, there is high velocity and hence low pressure, and since the air is not in motion here, or it comparatively is static, the velocity is low and hence the pressure is high. So air tends to move from high pressure to low pressure. That is how the air below tries to push against the surface, and thus creating an upward push called the lift. Now this is Bernoulli's principle acting in this setup. Just clearing this off. Coming back to Newton's third law. So same principle here. The air that is being blown towards the curved surface tends to stick alongside it because of Coanda effect. Now if you see, the air that is moving in this direction has been pushed down in this direction by the curved surface. So the air has the direction has changed. That means that the curvature has pushed the air down, and the curvature pushing the air down is the action. Now we know from Newton's third law that every action has an equal and opposite reaction. So as much as the curved surface pushes the air down, the air pushes the curved surface in the opposite direction with the same magnitude or with the same effect, and this upward push is called the lift. And in the example of the impeller got pushed up, and in the example of the paper which was drooping downwards got straight. Now coming to this example where the paper was bent in 90 degrees, or where the impeller setup had a flat surface attached to it, the air that is moving in this direction does not stick to this downward direction, or does not divert into this direction, because there is no curved surface that is being guiding the air in that direction. So that's why the air just goes forward. So there is no act of Newton's third law here, because the air is not being done anything or being pushed down in the case of the curved surface. Since it's not a curved surface here, the air is not being pushed down. So there is no point in talking about Newton's third law, as well as there is not much of a velocity difference across, because the air here is also almost static and there is air just moving here. So there is not much of a difference here. If it were a curved surface, the entire right side of the surface would have had um, low pressure because of high velocity, and towards the left it would have been low pressure, low velocity and high pressure, and then there was a pressure difference. But since there is not much of a difference in the air motion here created by the surface, there is no high pressure, low pressure here, and there is nothing happens here. The Coanda effect, the turbine setup also does not have the paper, nothing happening there, as well as the impeller setup. There also there's no lift generated and nothing happens there.